Okay, let's finish off dividing fractions now and tackle a few more examples to allow us to deal with the issues. What we've learnt so far is that dividing fractions is actually the same as multiplying fractions. Here, dividing by a half is the same as multiplying by 2, where this fraction here is the reciprocal of here. Then we use our cross-cancelling techniques those are both in the 2 times tables to get ourselves to an answer. So, let's just tackle a couple more to make sure we are up to speed. So, first thing we do is remember that dividing by a fraction is the same as multiplying by the reciprocal. It's this part that changes. Remember to keep this the same. Now we set it up for our cross cancelling, just like with multiplying fractions. Now, I can see 16 and 4, so I'm going to divide both parts by 4. I can see 5 and 25, so I'm going to divide both parts by 5. Just a reminder, this step isn't necessary. You can do it straight from here, but I prefer because it's clearer. Hopefully by now you've got a feel for how the topic works, but what we need to do is tackle a situation that we haven't come across yet in these examples. Can you think of what that might be? That's right, it's mixed numbers. Now, I'm just going to change that number to a 3 to make this better. First thing we did when we were multiplying fractions with mixed numbers is we made them into improper fractions. Each of these 3 whole ones is made up of 3 pieces, so that's 9 pieces, plus the extra piece gives me 10 pieces. Over here it becomes divided by, 1 whole one is 3 pieces, so that's 3 plus 2 more is 5. No, I haven't changed it to a multiply yet. I'll do so now. Okay, and then I'll go for some cancelling. 3 and 3. Aha, these divide by 5. 2 times 1, 1 times 1. Ah. So, the same approach as before. Make improper. Convert. Cross cancel. And then calculate. Now, the answer here is an interesting one. It's a bonus. Should we have seen this coming? I've got 10 thirds, and I cut that into 5/3 portions. So here's 5/3, and here's another 5/3. That makes 10/3. So the answer of 2 could have been something I spotted earlier. Let's look at another one like that. I've got 16/7 cut into 4/7. That's 4/7, 8/7, 12/7, 16/7. What you're noticing now is that actually, when the denominators are the same, these sums become easy. Because remember, the denominator tells me how many pieces are required to make a whole one. So it tells me the size of each piece. Well, if the sizes I'm dealing with are the same, and it's just, I've got 16 pieces and I want to divide them into 4s. I suspect then that you could do this sum really quickly. That's right, because the pieces are the same size. 25 pieces that are this big divided by 5 pieces into 5s that are the same. So division of fractions. Make it improper if it's not already. Convert using the reciprocal and the inverse operation. Cross cancel and then calculate. What we've got to tackle next is how we would deal with a mixture of operations in a question.